So what would the graph of y equals -3 cosine x look like? So in blue, I've just drawn the regular cosine graph. So starting at 0, 1, goes down to 0, down to -1, back up to 0, and back up to +1. That -3 is a outside coefficient, so it's a vertical expansion compression factor. Now, because it's negative, it's going to vertically flip it as well. So we have a vertical expansion. So this is a vertical flip, and this is a vertical expansion by 3. So what ends up happening is we take that coordinate here, it gets vertically flipped and expanded to -3. The 0 point gets flipped and expanded, but it doesn't change since we're starting at 0. The -1 point gets vertically expanded and flipped. The 0 points don't change, and that +1 point gets flipped to -3. So what ends up happening then is our graphs look like this, and we can draw our 4 quadrants in, and we end up with a vertically flipped graph that has been vertically expanded. So that's the vertical. When we can also do a vertical expansion compression, we can do a expansion compression horizontally as well. And that's going to be happening based on this b value, the cosine of b theta. So b is going to be a horizontal compression expansion, and what it will do is it will vary the period. And how it varies the period is going to be done using this formula here. We just take the original period of 2 pi and we compress it by a factor of b. So for example, we have drawn here of y equals cos theta. This is just one period y equals cos theta from 0 to 2 pi. And if we do 0 cosine of 2 theta, it's a horizontal compression by 2. And what ends up happening is we end up with a period of pi. 2 pi divided by 2 gives us a period of pi. So the graph then, when we compress this graph is going to look like this. Our starting point is going to still be at 1, 0, 1, but now our ending position is going to be compressed to pi. So everything, one full period is now going to be fit between 0 and pi. So every coordinate changes. So if I take my reference point of 0 at pi over 2, it gets compressed to pi over 4. And we could check this because if we plug in pi over 4 for theta, we get 2 times pi over 4, and it gives us cosine of theta equals 0. Okay, so then what we're going to do then is take every one of these reference points, so the point at pi and -1, that point gets compressed to pi over 2 and -1. The point at pi over 3 pi over 2 and 0 gets compressed to 3 pi over 4. And then the 2 pi point gets compressed to pi. So we end up with our 4 quadrants that look like this. Okay, so we have a horizontal compression of 1/2. Now we can also keep track of this by just taking our end position and finding the middle. So that whole idea of finding the middle can be used here. We can divide up these 4 quadrants by first of all finding the middle halfway between the end and the start. And we can calculate that by pi plus 0 divided by 2 is pi over 2. And then again, we can find the middle between the midpoint and the start. That gives us the first quadrant. Between the midpoint and the end gives us the third and fourth quadrants. And then we can sketch in our graph based on those 4 quadrants again. So this is a nice way to keep track of the 4-part symmetry or the quadrant symmetry that exists in our cosine graph.